So let's take a look now at example number 2. Let's see what this problem says. At 4 a.m., the layer of ice on a lake was 6 inches thick, and its thickness is increasing. Here it is. Its thickness is increasing at a rate of 0.2 inches per hour. So notice then at early hours, right, if t is a small value, then the rate is actually really small. But apparently as time goes on, if t becomes a large value, then the thickness is being gained more rapidly. So it's increasing at a rate of 0.2 inches per hour, where t represents, this is important, where t represents the number of hours since 4 a.m. So if it was 4 a.m., t would be a 0, because it's 0 hours have passed. But if it's at 5 a.m., now we're up to t being 1. It's the number of hours past or since 4 a.m. Okay, so let's start to think here then about a question like part A. How thick was the ice at noon on the same day? Okay, so again, I'm just going to take a look here and think about what I'm interested in is the thickness of the ice at noon. That's what I'm looking for. But I should notice a couple things. First off, I can see that if I integrate the rate over the time period, I can easily figure out how much the thickness has changed. Kind of like up above in example 1 part B, we found out in this first half hour how much liquid had kind of left the tank. We found the change in the total liquid. So if we integrate here, we'll just find out how much the thickness has changed, but we have to keep in mind that it was already 6 inches thick. So what I'll have to do here is ultimately take into consideration the current thickness, and then I'll have to add on to that the change over, let's see, from 4 a.m. to noon, that would be over 8 hours. So let's go ahead and take a look at what this looks like. Now my current thickness, of course, is just 6 inches. But to calculate the change, I would have to integrate the rate, and I would have to integrate this over the given time period from 4 a.m. to noon. Now again, a lot of people are going to go through this really quickly, and they would have written something like 4 to 12, but that would be definitely wrong, because I have to remember that t here represents the number of hours since 4 a.m. So 4 a.m. is 0 hours past 4, whereas noon is 8 hours past 4. Again, here I have a nice simple polynomial function. It's continuous, so I can use fundamental theorem of calculus part 2. So this is going to be 0.1 t squared evaluated from 0 to 8. Notice that if I plug in 8, I'm going to get 64 times 0.1, or 6.4. And if I plug in 0 there, of course, I'm going to end up with nothing. So I'm going to get 6 plus 6.4 minus 0, or a total of 12.4 inches. So a little bit over a foot. Okay, so I can see how I can imagine, again, using this idea of integrating a rate to find the amount of change. But notice then if I'm trying to find a total quantity, I have to take into account a current value. So notice how this is kind of compared to the question here in part B, which says how much thickness was gained, so not how much total thickness is there, but how much thickness was gained from the period of 6 a.m. to noon. Okay, so if I'm interested in calculating the thickness gained, then I can just focus on integrating the rate at which the thickness is increasing. And if I'm going from 6 a.m. to noon, I already know that noon is 8 hours away from 4, and 6 a.m. would be 2 hours away. So again, I'm going to integrate here. Since I have a nice continuous function, I can use fundamental theorem part 2. So I can see here that I'm going to end up with 6.4 minus, and if I plug in 2, that's going to get me 4. So I'm going to get minus 0.4 after I multiply by the 0.1. So of course then this is going to get me a grand total of 6 inches, half a foot. So in this 6-hour time period, there's a total of 6 inches of thickness that are gained.